Welcome to Lesson 4 of Module 1.3. In this lesson, we will explore how modern farming is being transformed through precision agriculture, which uses advanced technologies to monitor and manage crop and livestock production with unparalleled accuracy. Precision agriculture is a data-driven farm management approach that uses cutting-edge technology to observe and respond to variability in crops and livestock with pinpoint accuracy. The goal is to maximize productivity and efficiency while minimizing waste and environmental impacts. Now, let's break down key components of this system. GPS and GIS systems. These are used for mapping fields and handling spatial data, allowing farmers to manage their land with pinpoint accuracy. With GPS technology, farmers can track where they've applied fertilizer, water, or pesticide, ensuring they only use what's necessary, reducing waste and cost. Let's break down key components of this system. GPS and GIS systems. These are used for mapping fields and handling spatial data, allowing farmers to manage their land with pinpoint accuracy. With GPS technology, farmers can track where they've applied fertilizer, water, or pesticide, ensuring they only use what's necessary, reducing waste and cost. Remote sensing. Drones and sensors monitor crop health, soil moisture, and other field conditions in real time. This data allows farmers to make timely and informed decisions, whether it's watering, pest control, or adjusting planting strategies. Variable rate technology. This is a key technology in precision farming. It uses GPS-guided equipment to automatically adjust seed, fertilizer, or pesticide application based on specific field needs. This technology eliminates the one-size-fits-all approach to farming and tailors every application to the field's unique characteristics. Regenerative agriculture and carbon farming are two related trends that aim to restore ecosystems and help mitigate climate change. Minimized or no tillage. By reducing tillage, we protect soil structure and preserve important soil organisms, linking to healthier soils. This practice also helps with carbon sequestration, storing carbon in the soil rather than releasing it into the atmosphere. Cover cropping. This technique involves planting crops between regular planting seasons to prevent soil erosion, improve soil structure, and add organic matter back into the soil. Diverse crop rotations. Rotating different crops each season helps break pest and disease cycles, promotes healthier soils, and enhancing resilience to weather extremes. Agroforestry. Integrating trees into farm systems helps sequester carbon, improve water retention, and support biodiversity. Managed grazing. Controlled grazing of livestock can improve plant growth and soil health, fostering a more resilient ecosystem. Vertical farming and controlled environment agriculture. What is vertical farming? Crops grown in fully controlled indoor conditions, often in vertically stacked layers. Factors like light, temperature, humidity, and nutrients are carefully regulated by technology. How it works? Plants grow in soilless systems, hydroponics or aeroponics, under LED lights, with precise nutrient delivery. Sensors and AI optimize growing conditions, creating an indoor assembly line for plants. Key benefits. It uses less water than traditional farming, requires no pesticides, produces year-round with consistent output, and can be located near urban centers for fresher produce. As climate change poses increasing risks to agriculture, it's vital that farming practices become more climate smart. We can see some examples of water-efficient practices that support these goals. Using drip irrigation or micro-sprinklers, which can save up to 95% of water compared to traditional systems. Employing soil moisture sensors to precisely measure when and how much water crops actually need, preventing over-irrigation. Rainwater harvesting systems, which allow farms to store water during wet periods for use in dry seasons. And of course, cultivating drought-tolerant crop varieties which can sustain yields even under reduced rainfall. Moving on to adaptation strategies, actions that help farmers adjust to new climate realities. For instance, shifting planting and harvesting times can also help avoid crop loss during heat waves or heavy rains. Integrated pest management, or IPM, becomes crucial as new pests and diseases emerge due to warmer climates. Farmers are also experimenting with alternative forages for livestock to maintain productivity when traditional feed crops fail. In flood-prone regions, raised bed planting can protect crops from waterlogging and soil erosion. The Food and Agriculture Organization defines climate-smart agriculture as an approach that has three main pillars. Increase productivity, ensuring food security and profitability under climate change. Adaptation, helping farmers cope with new climate challenges such as droughts, floods, and temperature fluctuations. Mitigation, reducing greenhouse gas emissions through sustainable farming practices. The CSA involves practices like water-efficient irrigation, using drought-tolerant crops, and adjusting planting times to better cope with extreme weather conditions. These efforts not only improve farm resilience, but also reduce the agricultural sector's contribution to global warming. Sustainable energy integration is another key trend in modern farming. Agrivoltaics, the practice of combining solar panels with crop production, is a groundbreaking approach. Solar panels can be installed above crops or spaced among orchids. In fact, if just 1% of EU farmland adopted agrivoltaics, it could generate up to 944 gigawatts of solar power, more than the EU's total 2030 target. Additionally, wind turbines are increasingly used on farms in areas with high wind potential. This provides both renewable energy and income for farmers through feed-in tariffs. Biogas production is another method where agricultural waste like manure and crop residues are converted into biogas for energy. Lastly, energy communities are emerging, where local farmers and residents share ownership of renewable energy installations. This helps build resilient local economies and promotes sustainable development. Social farming is a growing trend where farming activities contribute to the social and therapeutic development of vulnerable groups, such as people with disabilities or long-term unemployed individuals. For example, in Italy, a national law passed in 2015 officially recognized social farming as part of the agricultural landscape. In the Netherlands, there are over 1,000 care farms. Agritourism is another emerging trend, especially in countries like Italy, where agritourismos have become an integral part of rural economies. These establishments offer farm stays, educational workshops, food and wine experiences, and recreational activities. By blending agriculture with tourism, agritourism helps diversify farm income and supports rural communities. The demand for sustainable, local, and transparent food systems is growing. The EU has set an ambitious target to increase organic agriculture land to 25% by 2030. Consumer demand for chemical-free, environmentally friendly products is driving this change. Local food movements are also on a rise. The Chilometro Zero movement in Italy promotes the consumption of locally grown produce, and the Locavore movement is gaining traction across Europe. Consumers today expect transparency. They want to know where their food comes from, how it's produced, and its environmental impact. QR codes, blockchain, and detailed labeling are helping make this possible. That concludes Lesson 4. Thank you.